Hello. Yes, ma'am. Let me make you as a host. Very good evening, everyone, as well as a good morning as well from our international teachers. Uh, let's start our day 3. I think ma'am is ready as well. Good evening, ma'am. Yep. So over to you, ma'am, to start the session.
Yeah, good evening, everyone. Good evening. Thank you. Okay, welcome to the day 3 of overview of Python class. So let me just give me 1 minute to share my screen. Yes. Okay, in today's class, we would like to cover the functions and something about the how does the Python will be can be called as object-oriented programming concept, or how does it follows the it proves the characteristics of object-oriented programming concepts like that. Okay, let's move on. So what is a function? Well, a function can be called as a just number of statements or a number of codes that will be performed when it will be called. Like, So as we have already learned about the print function or something like that, right? So print is an inbuilt function or more inbuilt functions. We have already learned that we will call that functions by the function name with its proper parameters or the arguments passed through it. And the function will do whatever it is or whatever it is supposed to do, right? Whatever the code is written inside that particular function's body or the function's definitions, we can call its function definitions, right? And the function will perform that, right? So the syntax of the perform now we will try to write something function customized, right? A user defined function, right? We will write now user defined functions. How can we define them? So to write a user defined function or to generate a function, we need to use that def command. Okay. After that, the function name will be there, and within braces, the arguments, the number of arguments will be passed, or the name of the arguments, right? So now, let's move on to some examples. So this is a print statement or the print functions, which has been called just as easy as this. So just hey Rajat is being passed within the print statement. So it will print that one, whatever is passed as the argument to it, and it will just print it, right? Since print function is supposed to do or supposed to print whatever is written inside the double quotation, it will print the entire part as the image or as just like that. It will do nothing. And if we pass any variable name, then it will write the value of that and like that. Okay. Now we will write our own functions. How? As I have told that for defining a function, we need to write def command. Def, then the function name, whatever the name you want to give, right? Like first function, then the open and close braces. Why? Because it's a no argument function, right? Since we have not passed any argument within this function. So it's a no argument functions, right? So after that, print here. We are defining the first function like with two print statements here. One is print hey Rajat, another will print like Rajat, how do you do? Like anything, we can define any variable, we can define any value here, we can use a loop, like any other programming language, whatever we can do inside a function, here also we can write. But here no braces, no opening braces, no close braces or like that, do done is needed. Just once again, indentation is very much important in Python, right? The definition or the body parts of the function can be explained or can be indicated by the indentation, right? Next. So after defining it, after executing it, let's see. So the first function is being defined, right? Now, if we call the function like first function, so it's being called and it's executed. The function is being executed. So it's printing the first line like, hey Rajat, and the second line like, Rajat, how do you do? Right? So this is a basic example of how to write a function or how to define a function. Got it? Next. Now, we will pass a single number of arguments to a function. Till now, in the previous example, we have not passed any argument, right? So now we will pass a single argument, like whatever a printer, a user will be given, will give an input, and that input will be passed to the function, right? Next. So, and what will it do? It will print that, hey, then that particular value, whatever the user will give like that, where in this particular use input function, right? And after that, this print function will do. So after defining it, we have executed it. So the function is being defined. And after that, name1 equals to input. So it's demanding some input. For example, A, B, C, D, like that. Okay, whatever it is, give just an enter. After giving an enter, so the function is being called. And after that, sorry. Okay, so now when the function here, the variable name is set, right? Whatever we have given as input, it's stored in this particular variable as name1. And after that, when we are calling this first function, by passing that particular name1, whatever the user has given, the result is like this. See, whatever we have given in the input section, it's saved in the name1 variable. After that, the name1 variable is passed as the argument to the first function. The username is the argument name or the parameter name, right? Whatever, it's passed to the print function here inside the function body. And here is hey, like whatever we have given. So here is again. So once again, we are executing it. Like we are giving a name, right? Say my name. Okay. And after that, once again, I'm calling the function. Now it's writing like, hi, hey, Sushmita. Sushmita, how do you do? Right? Got it? So we can pass the argument, or how to pass the argument, or how to call the parameter name. And parameter name and the argument name should not be same, or it's not necessarily as the same, right? Next. Now, here we will call a function from another function, from within another function, right? So we are defining a particular function, like first function here. And after that, in the second function, we will call the first function, right? So it can be called as just like a nested function like that, right? A function can also call another function. This is an example for that. So if you execute it, it will be executed. So first function and second function is being defined. So when we call the second function, we are calling the second function. And in between this, inside the second function, it is written that you need to give an input. So we are giving an input. And after that, by this input, the first function is being called. So from here, it will the cursor or the execution pointer will move on to there with the parameter value as whatever we have passed. So here, as username, the parameter name will be as username, and it's printed. The first function will also be executed. And after finishing the first function execution, the cursor or the execution pointer will come back to that point once again. Got it? So till now, we have applied function without any parameters or argument, function with parameters or argument, function that will be called from another function, right? Next. Until now, we have not written anything, right? The function will do whatever it's supposed to do, or whatever is written in its definition part, and it will just go back to the execution pointer to the next line, right? Now, what to do if you want to store the value, or if you want to return the value that will be executed, or that will be calculated, or that will be some value from that will be fetched from a particular function. For that, we need to return. We need to use the return command or the return statement, right? The function, when the function returns some value and the value will be stored, we need to store that value in a variable. We need to apply, or we need to use return. Okay. So here we are applying, or we are just defining a function named as times. Okay. With, two parameters, x and y. And after that, a z value will calculate just the multiplication of x and y, and it will return z. So when it will return something, there should be someone who will catch, or who will save the value, right? So for that, we need to do what? Now see, here we have C who is there to catch the values. Whatever the times functions will return by this function, or this value, or this statement. The value whatever that will be calculated in Z will be returned and it will be stored in C variables, right? This is the concept of returning value from a function. So we are calling the times function by the value 4 and 8. That means for X, the value will be 4. For Y, the value will be 8, right? So that will be multiplied. So 4 and 8 will be multiplied and the result 32 will be saved in Z variable. After that, Z variable will be returned and the value, that is the 32, will be returned. 32 will be caught by C. And if we print the value of C, 32 is being printed here. Okay. So this is the, concept of return statement, how to return a particular value. Okay. Once again, there's an example that we have applied, or we have just added another variables here, like Z is being there to calculate the summation or to fetch the value or to store the value. And after that, we are passing that value to the return function, right? But we can also give that equation directly in the return statement and it will work properly. Okay, here. After calling this function, the result is given here 20, right? Since 4 and 5 are the values, so 4 and 5 is being multiplied. The multiplication result will be fetched or will be returned to the wherever the function is being called, and the value is stored in C, right? So C is the variable which is catching the value, whatever this time function returns. So the answer is there, right? But difference between till now, actually, I have already learned about C, C++, Java, like that. So in these languages, return function is there, but return function can only return a single value, right? A single value or a single variable, value of a single variable, like that. And the variable who will catch or who will store the value, whatever the return statement will return, there was only one variable. But in Python, there is an advantage that return statement can return more than one parameter or more than one variable's value. Okay. So here we have assigned a list named as example list or EG list, rather EG list, with these kinds of value, 10, 50, 30, like that. Okay. And we are defining a function, EG function, by passing the EG list. That means the list is being passed. So here in this example, we get to know that a list, not only a particular variable, but an entire list can also be passed as the parameters, right? So the list is being passed and we are applying, like, highest is a variable who will catch the, or who will store the highest maximum value from the list. So the maximum value is like 100, right? And lowest is the maximum value of the, minimum value of the list. So the minimum value is like 6. And first is the 0th element of the EG list. So who is the 0th element of the EG list? That is 10. So 10 will be stored in first, and in last, minus 1th element. Minus 1 means, once again, a little bit revision about the previous class. Minus 1th position of a list is the last position. So that means the last position is 100. So it will be stored in the last variable. Now it's returning all the 4 variables, like highest, lowest, first, last, all together, right? And if we call the value, right? If we call the function directly, see what is happening here. It's returning the values. See the difference. Okay, 4 values. It's returning the 4 values, the highest, lowest, first, last. And when we call the function, it's there. The printing is there. Okay. And of course, here is no variable we have assigned, but we can assign the variable like this: A, B, A, comma, B, comma, C, comma, D. That means since 4 variables or the 4 values will be returned, so 4 variables we need, and these variables will be written by applying this comma operator in between, right? And EG function is a function name which we have defined here, and the EG list, that is the list, is being passed, okay? And here we are printing the value of A, B, C, D. That means the sequence is very much important. The value of A will be the value of highest. The value of B will be the value of lowest, like that. Okay? The assignment will be like that, first to last. Okay? And the printing, we are printing the value like A equals to value of A, like that. So here is the result, right? A equals to 100. That means the highest one. So B will store the lowest one, that is the 6. And C will store the first one, that is the 10. And D will store the last one, that is once again 100. Got it? So when we call or when we return a value, or when we return the value of by a particular variable, then we can catch, or we can apply, or we can use some variables to catch the result or to catch the values, as well as we can't. If we do not use any variable, it will still print, right? And if we use the variable, obviously it will store them. It will be stored them. The value will be stored in that particular variables, but in proper sequence. Got it? Next. Now, what if that we want to pass a number of variables that we don't know when we are writing the code, or when we are defining the function, we don't know how many numbers of variables that will be passed as the argument to that function, right? Then what we need to do? For that, we need to write in the parameter name like star args, right? Args will take whatever the value will be passed, one by one it will store, and one by one it will be used. Okay? Here, if the number of argument is, that is to be accepted by the function, is not known, then asterisk symbol is used. Okay? So here, RDS equals to, we are just assigning that we will add the value, right? We will add the value, whatever is passed in between the, or as the argument will be calculated here. This is the function definition. And here we are putting, taking a blank list here, and we will append them. One by one value will be taken, like one. First star args will take the total, right? So the star args will take the total number of arguments, or to entire value which we have passed as the argument. So we have passed here like 1, 2, 3, 4, 5. So args will store all. And we are applying that for I in args, whatever the number is, one by one append, right? So that means what? One by one number will be taken from the args, and it will be added to this res list, named list, right? To this list, which is named as res list. And we are printing the res list like this one. And if we apply the sum of res list, we are returning the value like sum of, so it can be called that a sum of numbers, right? This function is doing like sum of n numbers, right? Whatever the numbers we can give at the time of say input, or at the time of execution, or at the time of function call, it will return the sum of numbers, as well as the numbers will be stored in a particular list. So that is the definition, function definition. And what I need to do, once again, if you don't know the number of arguments which will be passed to a particular function, then just you need to put an asterisk sign symbol before the function name, right? And it will be done. Okay. Next. Keyword argument. Keyword argument means, here we are just look at the example, right? So we are defining a function like key exam, okay? Key example rather, the name should be, right? So key example where the parameters are f name and l name, right? if we call at the time of function calling, we can use these key names or the parameter name for passing the values, then that will be known as keyword argument. We are using the keyword parameter name as the keyword which value we are giving. Now look at the example. We have applied that fname and lname. These are the parameters name. And the function body or the definition of function is just it will print them, right? Two variables will be printed. And at the time of function call, we are writing here like lname equals to 50 and fname equals to something, some string, right? So that means no need to define the data type, no need to define or it's a string or integer type like that. Don't need to, no need to write that. It will just, we will just send the value and it will be caught by the parameter name. But here we are applying the keyword as argument, right? What? We are applying the parameters name here. That means we want to say here that for lname value, the value will be 50 and for fname parameter, the value will be this one, right? If we don't use the keyword, whenever or whatever we will write that at the first position, that will be stored as the first parameter value, right? But if you want to change the sequence or if you want to change the portion of the change the sequence of the value, which will be passed to the function, then we can use the keyword name or the parameter name, right? Here fname equals to argument. So after executing it, the result will be like this. The first name is this one, argument. So whatever we have sent as for fname parameters, it will be stored in the fname, and whatever we have said that lname equals to 50. So the last name, the lname is got 50 number or 50 as value, and the last name, this particular line, this particular print statement will fetched, will be executed, and it will give you this particular output. Got it? So this is the concept of keyword argument. Okay. One more example is there. We are defining a get sum with a and b as a parameter name. And we will just do the sum here, like a plus b. Sum will be stored and it will return. Now we are assigning the value like x equals to 3 and y equals to 2, whatever it is. Okay, now we are calling by a variable that will catch the result, which will be returned by this particular return statement that will be stored in Z, right? Now, at the time of function calling, we are passing that b equals to y. First, we are writing that b equals to y. So if we don't write that b equals to y, if we only write that y comma x, then the value of y will be stored in A and the value of x will be stored in B, right? But when we are writing like b equals to y, that means what? The value of b parameter will be saved or will be taken as the value of y, whatever is saved, right? Whatever is stored in y or whatever is pointed by y variable, that will be the value of b parameter, right? So this is the concept of keyword argument. Next. Okay. Now there is a concept of global and local variable. That is the scope of the variable. Now what is the scope of the variable? Scope of the variable means for which particular variable, which portion of the code, which portion of the program code can be usable. For which particular program code that particular variable is being usable, okay, or accessible is known as global and local variable, right? Now in this particular function, let's move on to the example. In this particular function, like we are defining an function 1, and inside that function, we are defining another function, right? So a function can be a definition function, or the entire function body parts, or the definition of a function can be a part of another function or can be a definition of another function. Okay, that is also a unique feature in Python. Okay, so here we are defining EG function 1. In between that, we are defining EG function, third function here, right? With argument arg1 and it will do something. Okay. Now let's see. EG1, we are defining a list 1, 2, 3, 4, 5, right? And we are printing. So after defining this, if we run it, if we execute it, the first it will do where inside the function part, just see the example properly. This portion is for third function only. The body part or the scope is this portion. And for EG function, this is the definition, right? So now if we call the EG function 1, then the execution pointer will come here. After that, the execution pointer will move here. Since this is a definition, right? So it will not be executed till the function is being called. So the execution pointer will come to this point. So the list will be set. And after that, this particular print statement will be executed. That this is happening before the function call. So this is the output line for that. So whatever the value of EG1 is being printed. Like EG1 is 1, 2, 3, 4, 5. So the value of this is happening before the function is called. So the value is like 1, 2, 3, 4, 5, right? After that, the execution pointer will come to this line, right? Now the third function is being called with the easy list as parameter passed, right? So next, move on to the function, or the execution pointer will come to this particular line. The ARG1 will be the parameter, or will store the value of the EG1 list. Just remember, EG1, only the copy of EG1 is being passed to the ARG1, not the entire EG1, right? Since EG1 is the variable of EG function 1, and we are passing it to third function. So only the, only the copy of that particular list will be fetched or will be sent to the function as the parameter, right? So here we are assigning that EG2 equals to ARG1 0, 3. That means from 0 to 2, 0, 1, 2. This particular location 0, 1, 2 will be a value of EG2, right? And then we are appending 6, or we are merging, or we are adding the new value 6 to the EG2. So what will be the value of EG2 here? Like 0, 1, 2, right? 0, 1, 2 position of EG1 will be copied to EG2. That means 1, 2, 3, and after that 6 will be appended. So 1, 2, 3, 6 will be the new value of EG2. And here, this print statement will be executed then. And for that, this particular line is the output of that print statement. Like this is happening inside the function. And 1, 2, 3, 6, the value of EG2. Once again, I'm repeating. EG1, the value of EG1 is 1, 2, 3, 4, 5. It's being sent to third function as parameter, but only the copy will be sent here. And from that particular copied list, 0 to 3, less than 3, that is 0 to 0, 1, 2. These 3 values will be copied, or 3 values will be the elements of EG2, and we are appending, or we are adding a new value to EG2, right? So the new value of EG2 becomes 1, 2, 3, 6. And after that, after finishing this line, the execution pointer will come back to this pointer or this line, and this line will be, and this print statement will be executed. And what it do, it's printing the values of EG1, right? So this is the value of EG1 here. It's not being changed. Got it? A global variable can also be defined in another cell also. Okay. So that means what? This was a local variable to EG function 1, right? EG1 was the local variable to EG function 1, whose copy is being sent to third function, right, as argument. Now, we are applying here like EG1 in another cell, right? EG1 equals to 1, 2, 3, 4, 5. And after that, the same function is being written here. Whatever it's written in the previous code, it's written here. And after that, now look at the example. If we execute it, what it prints? First EG function, when we call the EG function 1, the EG function 1 will be called. The cursor point, the execution point will come to this line. The EG function 1 will be printed. So this is the line. It's being printed. After that, the third function 1 is called. The third function with the parameter this one. And we are saying that global EG2. That means we are defining EG2 as global variable, right? So that means what? Now EG2 can also be accessed by EG function 1. In the previous example, just see here. Yes, EG2 was only the local variable for third function. If we want to print the EG2 here, it will give an error, right? But if you define it as global EG2, then EG2 will become a global variable. And we are assigning that EG2 will take the values from the arg1 list, which will be a copy of our EG1 list, right? Since we have passed the EG1 argument, here EG1, the copy of EG1 is there. And from that particular copy, from second location to less than fifth location. That means, so look at the list here. Second location means 0, 1, 2. So 3, 4, 5, right? 3, 4, 5 will be the value of EG2. Now print EG2. So EG2 is being printed here, 3, 4, 5. And now we are adding a value 6 to EG2. Got it? Now see what? Here. Now what is being done? We are printing the value of EG2. That means the value of EG2 becomes 3, 4, 5, 6, right? 3, 4, 5 was the previous value after slicing from the arg1 list. So the value was 3, 4, 5. And after adding the value 6 to it, the value becomes 3, 4, 5, 6. So this is the line is being printed for this particular print statement. So the value of EG2 becomes 3, 4, 5, 6. Okay. And now we can access the EG1 from the function here. Sorry, it was already printed. So then now after this print statement, the execution pointer will come back to this line and it will move on to this line, right? And so the value of EG1 remains same since it was, sorry, since it was local to EG function 1, right? But from EG function 1, we can also access the value of EG2. Because of what? Because we have assigned the EG2 value as global. So it can be accessed by any function of this particular cell. Got it? Though it was an a variable of an inner function. So that should be a local. But since we have used the global keyword, so it's being global here, globalized here, or the variable becomes a global access. So with outside of the third function, we can also access the EG2. Got it? So the value of EG2 is being printed like here, 3, 4, 5, 6. So this is the concept of global and local. If you want to print or if you want to assign a particular variable as global, you need to apply this particular keyword, global. Then it can be accessible from any of the function from that cell. Okay. Next. Okay, I think it's clear. Next. Another kind of function is there in Python. A little bit just definition is being there. I will just mention, I would like to mention here, that is lambda function. Okay. Lambda function is almost similar like whatever function we have defined, but the difference is that it's a small function, only a single line function, and without any function name, right? An anonymous function, that is without any function name. Got it? So this is the definition of function. Those who knows the C language is like that, we would like to use the macro, right? There was a macro which is needed to be defined, has defined like that, and we can use that particular variable or the particular name of that function anywhere, like. So a little bit similar like that with the macro, right? So for that, we need to use the lambda keyword, and then this is the argument, whatever we need to take. This X is not the function name. This is only the argument. Got it? Or the parameters. Okay. So if you call the variable name by the parameters or by the argument which is being passed, or by the value, this particular 8, the value will be stored in X, and this value will be calculated. Whatever the equation is, or whatever the definition of the function is, it will be calculated or it will be executed, and the value will be returned. Since there is a lambda, so this X is the parameter name, not the function name. Just remember, okay? So lambda is a keyword for defining a lambda function. X is the whatever you done, I need to write not only X, whatever you may write the parameter name here, and then put a colon, and then the body part in a single line, a single expression. And after that, when we need to call it, we will just call the variable name in which the lambda function is being defined with, in between the braces, the value will be passed, which will be taken as argument by the lambda function. Got it? Next. Okay. Now, an important topic is that exception handling. What is the concept of exception handling is? For example, if you want to divide by, divide a number by another number, right? And you have mistakenly passed a number like 0 or like that. So it may produce an error, right? Divide by 0. It cannot be possible like that, right? So to handle an error, there is an exception handling in most of the languages. So Python do have also, right? So in exception handling is a mechanism in Python that allows you to handle the error and unexpected error events that may occur during the execution of your code, right? Now, how to write the code syntax? The syntax of the exception handling is like that. Write a try. The command name or the keyword is try. Then the code, whatever the code in between the try portion will be there. After that, what exception can be there? The possible exception with the exception type, and the code for that particular exception, that what will it do when this particular exception is being caught, right? And then else, if there is no exception, then what will it do here? And after that, finally block, that whether it caught an exception or not, the finally block will be executed, right? Now, see an example here. So we are defining a function like divide number, like A and B. The two numbers will be there, like A and B, and the result will be like A by B, right? And it will print the result. If we give a proper value for A and B, the result will be given, right? But if you give any of the value as 0, then it will return, it will be caught by this exception handling, that 0 division error. And inside the exception part, the body part is defined as print statement. Only a print statement is there, right? Now, if you call the function divide number by the value 10 and 2, the value is being printed. The result of the division is obviously it will be divided and the 5 is the quotient part. So it's being printed, right? But if you call the function by 10 and 0 or 0 or 10, whatever it is, then this error or what this particular exception will be caught, right? And this particular line print statement will be executed. Got it? So this particular statement will be skipped. When we give the value, it will try. When it's going for try section, it will see that there is an exception, there is an error, right?
Ma'am, just one request. They are asking to if you can increase the font size. I think.
Okay, it's already increased from previous day. Okay.
Okay, I think it's better now. Thank you.
Okay, yeah. Since if the increasing the font size, we can't see the entire code in a single page like that. So
Correct.
That's a little bit problematic. I need to scroll up and scroll down several times, right? Anyway.
Yep.
Anyway, so divide number when we are passing the value like 10 and 0, so the value will be there, and it will catch an error, right? There will be an error generated, but we have applied the try catch block here, so exception will be caught here, and this portion of the code will be executed for that particular line. So whatever written here, error is division by 0 is not allowed. So this particular line is written here or is printed here, right? Next. Okay. So next, multiple exception. In the previous example, just we have catching only one exception, like that was on only divide by 0 like that. Now, if you want to catch multiple kind of exception that can be happen in your program, then you can write multiple except block, or you can also write a single except block. We will move on to that example, but let's just print this one. Here it's demanding for a number, right? It's enter a numerator value, like for example 10. Enter. Now it's wants a denominator value, like for example 5. Sorry, 5. Okay, so we have given two proper value, so the result is being printed. See, the result is division. But yeah, once again, I'm executing it with the value 0. We are passing 0 as a value and give the enter. And it wants again the denominator 0. So since we have given the 0 as a denominator value, the 0 division error is being caught, and this particular print statement is executed here, right? You have divided a number by 0, which is not allowed. Got it? And once again, we are passing a alphabet as the number, which is actually a value error, right? It wants some numeric value and we are giving an alphabetical value. See, for the first value, we have given a string, a number, character value, that is an alphabet K, right? And at that particular time, the exception is being happen here, and this particular except is executed. Since it's not a 0 division error, right? We have not given a 0 as the value of denominator. So its value error can also be checked here. So this particular line print is being executed and the print statement is here. You must enter an integer value. So got it? We can also catch multiple exception in a block or in a block of code in our program. by using two except or the numerous numbers of exceptions. But we can also use a single except for multiple exception. There is an example, right? So once again, same code, just by using a single exception block. Okay. So we just executing it, just writing 10, enter 0. So we have given the 0 as denominator. So this particular code is being printed, executed, right? And these lines is being printed here. Got it? And once again, if you give some value error, like any alphabet D, then also it can catch the exception by this single except block. Okay. So in the except block, we are passing, we can pass multiple exceptions, right? In a single except function or single except keyword, right? And the exception block will be executed. Okay, so got it? So at the time of execution exception handling, we can catch single exception, we can catch multiple exception by multiple except block. We can also catch multiple exception by single except keyword or single except block. Okay. And what is the else block is? The else block is executed, will be executed when there is no exception is there, right? So here's an example. Okay. So in between try block, the result is there that A by B. So it will be divided, the value will be divided, the value of A will be divided by B. So if we call the function by 10 and 2, obviously it's good. So it will return the result here, and the result will be calculated and else part will be executed since there is no exception. Got it? And if there is an exception when we are passing or we are calling the value function by passing the value as 10 and 0, then there is an exception. So zero division error will be caught by this particular except block, and this print statement will be executed. So there is an output. Error division by 0 is not allowed. Got it? Just a minute. Got it? Next. The finally block. Now, what is the use of finally block? Finally block is, else block is what? If the exception is not, happen, then the else part will be executed. But if you give finally block, then that particular block of code will be executed whether there is an exception or not, whatever there is, right? So here, just execute it. Once again, divide number and print statement is there and exception is there, right? And when we are calling the function as 10 and 2, that means the value is printed here. It's good. Still, the finally block is executed. See, the division operation completed line from the finally block is completed. That means no exception, but finally block executed, right? And for the second calling function, 10 and 0, exception will be happen, right? So for exception, this particular line will be executed. Here is a result. And then also the finally block will be executed. So there is a complete result. For exception handling output here, and for finally blocks is execution here, right? So that means finally block will also be executed when there is an exception or not. For both of them cases, the finally block, whatever we have written in the finally block, it will be executed. Got it? So that is an idea about the exception handling in Python. Okay, next. Next topic is recursion. Now, what is a recursion is? right? We have learned about the functions. We have learned about the definite lambda functions, user-defined functions like that. Now, what is a recursion is? Those who knows about the function or in any languages like that, I think they have any idea about recursion, but still I'm just giving the concept here that recursion is when a function will call itself, right? A function call another function, right? We have learned it. But when a function calls itself, right, more than one times, right, or at least one times, then that particular function will be called as recursion. Okay. Here, to add a number of list, okay, by using a non-recursive function. This particular code is for non-recursive function to add the list of the numbers of the list or the elements of the list. Okay. So if you just execute it, the value will be here, like 1 plus 2 plus 3 plus 4. How? It sum this particular list. The value will be passed as the parameter to its sum function as a list. Result is the summation variable which will store the summation value. Okay, the initialized is as 0 and x in a list. That means x will be one by one value from that particular list, and result will add them, right? So result plus equals to x. That means result equals to result plus x. Okay, so got it. So one by one value from that particular list will be as x here, and it will be added to the result variable. And finally, result will be returned, right? And it will be printed. Okay. Now, what we need to do if you want to see one by one value is being passed, right? So we can write it as a recursion. How? See, first, this was the list here. We are calling the recsum function by passing that particular list, right? Okay, that particular list. Okay, so 1, 2, 3, 4, 5 is first value of the A list. Now we are checking that is the A list is empty. This A list and this list are not same. This is only the copy, right? We have already learned. So we are checking that A list is blank. If it is yes, then just return 0. Otherwise, it will do what? Otherwise, it will take the value of 0th element and it will call the function again by the list, entire list, starting from 1th element. See how? At the first time, the list is 1, 2, 3, 4, 5, right? So the value of A list is 1, 2, 3, 4, 5. So it's not blank. Come to the else part. So what is the value of A list of 0? That is 1. So now 1 plus recsum of from 1 to the end. From 1th position is what? This one. That means the new parameter will be this portion. For this particular argument, the A list is the new list that will contain 2, 3, 4, 5. Right? This is a new list. Once again, enters the function. A list is empty. No. Else part will be executed. Then 0th portion. This is the new list, right? So 0th portion or 0th element of the list is 2, right? So we had 1 in the previous section, right? We have already kept it. After that, 2 is being kept. And once again, recsum is being called by from the list, that is from 1th index to the entire, the last index. That means this was the new list till now. And now this function will be called by this portion. Got it? I think it's clear. So similarly, it will go on and it will be executed. 3 will become here and the other part of the list will be moved to the A list as argument, and then 4, we will have 4 by this particular line, and the 5 will be again called, right? 5 will be passed as the A list, and here A list, the value will be 5. Once again, this particular value 5 is being added. So we had 1, 2, 3, 4, 5 differently, right? So after that 5, the empty list will be passed in the parameter, and then it will become here, right? Empty list, yes. So it will return 0. So it will return 0 where? The last time it was called. Last time where it was called? 5 plus. So 5 plus 0 is returned here. So that means 5 plus 0, that is 5 and value, right? So that 5 will be returned to where it was called. Where it was called? After 4 plus. So that particular value, that is 5, will be returned to the 4 plus. That means 4 plus 5. So that means what? 9. So 9 will be the value. Now this particular 9 will be returned to where? Where it was called. Where it was called? After this 3, right? So 3 plus that part. So that means 3 plus 9. Now it becomes 12, right? Now this 12 is a number. There is no function no more anymore. So that 12 will again be returned to where it was called. Where it was called? After this 2. So basically that is the concept of recursion, right? I'm explaining the concept of recursion. Okay. So after 2, so that's 12 is being called returning here. So 2 plus 12, that means 14. Now this 14 value will again be returned to wherever it was called. Where it was called? After this 1. At the first line, 1 plus something something. So 14 was returned, right? 14 is returned here. So 1 plus 14, that means 15. Finally, 1 plus 15, 1 plus 14, that means 15 is an entire value that will be returned. And to X. X is here to catch that return value. And when we print the value of X, the value is 15 here. So basically that is the concept of recursion. And how to use that recursion function is, just here is a code example is here. Got it? Next. Factorial. One more example is there, factorial call. I think you all know that, right? That fact n is there. If the value of n is less than 0, so it will return no error. And if it is, n equals to 0, then it will return 1. Otherwise, it will return n into fact n. Got it? So that means n minus 1. So for the first time, if you call the value by 5, so 5 will be the value of n. 5 into n minus 1 fact. That means 5 into factorial 4, right? After that, 4 into factorial 3. After that, 3 into factorial 1, like that. Okay. That is the concept of recursion, right? Okay. And how to write it? That is our funda, or that is our target. So that is the code here. Okay. Next. Now, yes. Now, when in the first class, when I was saying that what are the characteristics or the advantages of Python was, I have said that it was it's an object-oriented language, right? Now, what is an object-oriented language? It's a concept of, there is a concept of class and objects like that. Now, what is a class? For that, we need to learn about what is a class, right? So those who know about something object-oriented programming, I think they know, but still a little bit, I'm saying like the definitions or the concept of class. Well, a class, till now we have learned about data types, right? Like int, float, string, list, set, like that. But class is a user-defined data type. Basically, class is a concept of user-defined data type, which will, and the body part or which can hold its own data member. And that particular data member can be of any type, any primitive data type. That can be an integer type, that can be a list type, that can be a string type, like that. Okay, but that particular string type or int type, that particular data member will be a data part or will be a part of that particular class, which is defined by the user. Okay, and also a function can be a member of the class. Okay, so a class can hold its own data members and function, member function. Got it? And of course, these particular classes or these particular data members and functions, data functions can be accessed and used by creating some instance. Well, class is basically a blueprint, right? It's kind of template. Okay, but it has no existence. It has no. It will not allocate any memory till any instances or any object or any existence of that particular class is being created, right? So object is an identifiable entity with some characteristics that the class have. Then the object will have the characteristics that is the member of the class is. Got it? So when the class is defined, no memory is being allocated, right? So that is the concept of class and object is. And how to use the class in Python. That is our concern. Here it is. Class, first class. Class is the keyword here, which is needed to be used at the time of defining a class. Okay. And then the name of the class, whatever you need to write, whatever you, you want to give as a name, right? And then this, since it's an example function or it's an example, this we need to write. We have not written anything. We just written that pass. That means it's an empty class. Basically, it's an empty class, right? We have written a class and just written as pass. That means it's an empty class. That also can be happen here. Okay. Next, in this example, we are initializing first class, a name, just a name. But with respect to that C, C++, Java, like that, there was object oriented is, for example, Java. So let's say Java. Okay. There was a concept of constructor, right? Constructor, destructor, like that. So constructor is used for what? Constructor basically is a function, is a member function of a class that is used to initialize the data member, the values of the data member of that particular class. Okay. So here, init is a default constructor. Okay. Underscore init underscore is a default constructor. Got it? So, but if you want to write your own constructor, then you need to write this one. Okay. Next. See the example. So, yes. We are defining here, just first class, we are defining the constructor once again, like this. Sorry. We also can, okay, we can initialize an object or we can instantiate an object by using the constructor as well as the function name, right? Let's see. So here we are assigning the values of the data member, like there are two data members like S name and S symbol. Sorry, name and symbol, right? Name and symbol is the data member here. And we are assigning the value that S dot name. Now, who is S? See, the first parameter of the init function, that is the S. This S is the name of the object that determines the name of the object. But we no need to pass the name of the object when this particular constructor will be called. Got it? We no need to pass. But always for constructor, the first parameter will be the name of the object and then the data member name, right? So s.name, the object name, the name variable of that particular object will be stored, whatever we have passed. Okay. And then symbol. Next. Sorry. Here. Now we are instantiating two objects, EG1 and EG2. First, EG1, we are calling the first class function, or we are creating an object of the first class by passing the values as ONE1 and number 1 as the argument of the constructor of that first class. Okay. So here, okay, just do one thing. Since class is, a little bit confusing, right? So the name of the class becomes first. So we are defining we are defining the constructor here, right? And we are calling the class, or we are creating an object named as EG1 by calling the function. That is, a constructor will be called, right? The constructor will be called when we are writing this by the class name. The constructor will be called. See, if you move your cursor here, it's been defined, right? So, and we are passing the value as string ONE1 and number 1. That means for that particular variable or argument name, ONE1 will be there, and for symbol, number 1 will be there. But for S, we are not passing anything. Automatically, EG1 will be passed automatically. We don't need to pass the object name. Okay. And after executing it, the objects are created, right? Objects are instantiated. That means memory location is being allocated by the value ONE and 1. Okay. And after that, when we are printing the value of EG1 name and EG1 symbol, here is the output. Got it? So two objects is being created here, named as EG1 and EG2. After that, for the data members of that particular objects, we have passed whatever we have passed at the time of object creation as the constructor, as the argument to the constructor name. The value is being stored and the value is being printed here according to the print statement. Okay. So how to create an object and how to write a class is clear here. Some more example. Yes. We have just changed the name of the object portion argument as self. Okay. Changing self name, so respectively, look, just change the self, right? Now see what? Self means we no need to write the our object name here. See. Just compare, yes, just compare the print statement. This line and this line. Self command, if you write a self keyword, rather self keyword at the space of object name parameter, that will reference to that particular object which is being created, and for that n name is automatically unique for that particular object. Okay. So that means what? Just see, just 1 minute. Got it? So one more example is like that. So when we are calling, okay, just wait, I need to execute this one, then this one, after that print. Okay. So 1 and 1 can be printed. So that means what? At the name, at this particular space, you can give S or self or not anything. Okay. That is only symbolize, or that is only determine your object name. Got it? Nothing else, only the object name, and you no need to write anything. Next. Yes. Just like global and local variable, as we have seen earlier. Okay. Here also, the classes can also have some variables as its data member, on the function name, or inside the function name, that will be local, right? So if you just initialize, or if you just execute this particular code, so test is already test, right? Now, if you call a particular constructor of this particular class to create an object here, EG3 is the object which is being created by calling the first class, is the constructor name of this particular class, and we are passing the value as 3, the numeric 3, and the numbers, the name 3, right? The string 3, okay? And then this name will be as 3, and and this symbol 3 will be as numeric 3. But for each and every object of this class, test will be as value whatever we have given. That means what? If you write any data members as a fixed value, or any fixed value data member is there, that particular data member will also be a part of the object of each and every object of that class, right? We no need to construct, or we no need to write anything, or we no need to pass the value for that particular variable or by that particular data member of that class. So now when we are printing eg3.test, right, we have not passed anything for test since it's already defined here. So this particular test string is set for eg3 automatically. It's just like any other language, right? If you know any other object-oriented programming, it's almost same. The data member, that means what? All the data members and the data function, member function, will be the part of the object of that class. All the object, be it is passed in the constructor or not, it will be a member of that particular object. Next. Okay. So in this example, we are doing what? We are passing two values, name and symbol, and after that, in a function, member function, we are passing the object. So now we can see that we can pass an object to a function by just applying the object name of the constructor. Whatever you written here as an object name, be it S, be it A, B, C, self, whatever, you can just pass that name and the entire object will be passed to that function. Okay, so passing an object as argument, that is very easy here. Just write the object name or the variable which is being used as the object name portion in the constructor part. Okay, next. So when we execute this particular code, we are creating an object EG4 here. And for the EG4 first class, that means the constructor will automatically called, this particular constructor will automatically be called by the string 5 as name will be stored, and the number 5 will be as symbol, right? And after that, we are calling the square function, eg4.square. That means this function will be called by eg4. That means for self, for our parameter C here, we have not sent anything here, right? That also can be seen that for each and every member function of a class, the object portion or the variable name which is being used as the object portion name should be as the parameter or the argument for each and every member function. Be there any parameter more than one parameter or not, but that particular value will be there. Okay, if you just forget to give it, it will generate an error, right? Just omit it. Okay, but you can't pass the object here, right? If you want to pass the object, you need to write it. Got it? Otherwise, you cannot access the particular object's value or the data members of that particular object. Here. Okay. So when we are calling the EG4 of square, that means EG4 will be passed as self and the value of EG4 of symbol. What was the EG4 symbol was 5, right? So EG4 dot symbol into EG4 dot symbol. That means 5 into 5. So 25. 25 will be the result. So here, we can also call the function directly by passing the value without using the argument, or we can use or we can change the number here. See this particular example. Here, multiply, the value is there. So if you pass the value at the portion of x, the symbol, the value of symbol was 5, right? So 5 into x, this one. Okay, so we can call the value or we can call the member function by using the object name. Next. Just a minute. Here, there is another example of calling the member function by just calling the class name dot member function, and we need to, okay, just see, we can pass the name of the object here. Here, this EG4 is the, just a little bit up, yes. See the definition of multiply function. There was 2 arguments, right? Self and x. So now we are passing the object name and it will be caught by this particular self. And the value of x will be like whatever we have passed after that, 4. That means we can call a function by the class name and by passing the object directly. Okay, got it? Okay, one more example we can have here. We will once again call the square function by passing the object name. See what is happening. See. Okay. Why? Because in the square function, there was only one argument, right? Takes 0 positional argument. That is the concept of positional arguments here. Okay. So that means for positional argument, since there is no need to pass the object name, right? But if there is any one more value or any more one more variable is there, or any one more argument is there, we can call it. Okay. Next. We have seen the none value, right? In the, I think in the first class, we have learned about the value none. At that time, we have no idea that what can be the value or what can be the use of that none is, right? Okay. So here's an example for that non-valued element. There is a class like math operations. After that, we are creating a member function like add, where the object name portion is there. And then the parameters are A, B equals to none, C equals to none. That means what? At least one value should be passed as argument when this particular add function will be called. At least one value. And for B and C, it can be none. That is automatically. That means initialized as none. Got it? So, and in between the function, inside the function, if B is none and C is none, the checking has been done. then it will return the value of A. If we have passed only one value, then B is none and C is none, obviously, then it will return that value. Else if only C is none, if C is none, then it will return A plus B. That means what? We have passed two value, right? Now B is not none. B have something value. Then it will add and return. Else, everyone have a value. There is no none. That will do some addition, right? A plus B plus C. Okay. So here, when the function is being called, let's see the output section. Yes. Okay. So here the function is being called. That means whatever the value will be returned, that will be stored in math_ops alpha variable, right? And here is the function call. Result1 equals to math1.obs, and we are passing only one value. That means only the value of A. That is, it will return the value of A, right? See, print, the 5 is being returned. After that, we are calling 5 and 10. That means A and B. The value of A and B is sent. So C is none still. Okay. So value of C is none. That means this portion will be executed. So A plus B, that is 5 and 10. 5 plus 10, that is 15. Sorry, 15. And for the last calling, function calling, that is 5, 10, 15. Right? So this particular statement will be there. So since we have already written none, if you pass any one argument, still the code will be executed. If you pass two arguments, still the code will be executed, and the second variable none, the value of none, will be overwritten. Right? So this is one concept of, or one use of none. When we when there is a when there could be an option that at the time of function call we can pass or we can change the number of argument, or we can pass less number of argument, so then we can use that none variable or the none value here, right? So that is the one concept of none value. And of course, concept of parameter passing, right? Number of, though there are 3 parameters, but we have sent only 1 parameters like that at the time of function call. Got it? Next. One more characteristics of operating, object-oriented programming is inheritance, right? Now, what is inheritance is, if there is a class, for example, say there is an animal class, right? There is a class like animal. So animal do have how many legs, ears. These are the common characters or common data members or common parts of the body that every animal has, right? So we can classify, and after that, if you classify the animals like class dog, then there could be a differentiation like the sound or the barking sound, right? Or you can say the number of legs, like that. Or you can say that similar feature like color of body, like that, size of body, which is specific for that dog. But for animal, legs can be 4, legs can be 2, like that. So number of legs, the data member or the variable number of legs can be there. And at the time of creation of the dog class, we can inherit, right? Inherit means if something is in a class and one more class is to be defined, which is having the similar activities or similar portion of the previous class, as well as some specific characteristics, right? Then we can do what? Then we can do inherit the previous class, right? And only the exception part or the unique part is needed to be written in the second class. So that is the concept of inheritance. Okay. And how to use it in Python. Okay. Here, we are defining a class as software engineering. Okay. So at the class software engineering, there is a constructor that init, self, name, age is there. and name equals to name, self equals to salary is another member function, which will take a value and it will set the data member money equals to value. Okay, one more thing I need to explain here, that as in Java or like that, we no need to initialize the data member exceptionally or data members except or outside the member function. Whatever we are writing inside the member function, that will become the data member for that particular class. One thing I have just forgot to mention this, right? So the number of data members for that software engineering class becomes name, age, money. There will be 3 data members for software engineering class object, right? Name, age, and money, right? We no need to write that name, age, and money after, inside the software engineering part without any using or like outside this member function. We no need to use it, right? Next, after that, we are creating an object of that software engineering class. Okay. I have not executed it. That's why it creates an error. Okay, so a object is being created here and passing by Karthik as string as name and age as 26, right? And now we are calling the salary function by passing the value 40,000 as the value as position. So the value, the data member money will be assigned 40,000, right? And after we are printing self name earns self money. That means self is the object name, right? So object name is A dot salary is 40,000. So that means when we are executing it, it's printed that Karthik name we have sent Karthik, then earns, then self dot money that we have sent 40,000. So it's been printed that Karthik earns 40,000. Got it? So that is a single class, right? Now one more single class is there, individual class, like artist. See, we are executing it, right? So after that, we are creating an object. Okay, now artist class is having name and age same as the software engineering class, right? Name and age. And money, here also this function is same. The money data member will be initialized by the value whatever is passed in that particular function, right? And we are creating an object here and we are calling the money function by 50,000 and we have passed this value now, right? Nitin and 20. So the name becomes Nitin, age becomes 20 and the value the money becomes 50,000, right? And the art form is another one function. So this part is unique in this artist function, artist class, right? The previous part, the name, age, initialization, and the money function is same as the software engineering class, right? Only this function, this art form is unique here, right? For that, we can use the inheritance without writing the artist function. Again, we will just inherit the software engineering class and we will use that. How? Let's see. Now, after when we have called this function, it's being printed like name is like that. Okay. Now let's see what I need to do if I want to apply the. Once again, I need to execute this class. Yes. Now, if you want to inherit the class, the syntax is like that. Class, the class name, within braces, we need to pass the another class name which is needed to be inherit or which is the base class, basically the base class name, right? So at the child class name inside the braces, we need to pass the parent class name or the base class name. Got it? And it will be inherited. And inside the artist function, see, we are just defining the art form here and nothing else. since the entire part is also already been inherited from the software engineering class. Okay, this part was only unique, so we are just calling it, right? Then after executing it, now see what? We are creating an object of this artist class by passing the name and age. But in artist class, there is no name and age, right? So where is the name and age? That is inherited from the software engineering part, software engineering class. So this name and age will also be usable for artist class since it is inherited. That means what? For that particular object, name will be Nishant, age will be 21, and we can also call the function of the base class by the child class object and by passing the value, right? And the result is this: Nishant earns 60,000, right? And also we can call the function of the child class here by calling or by applying the child class object. Got it? So that means what? The data member and the member function of the parent class is accessible here by applying the inheritance property. How? Only passing the base class name as inside the braces or as a parameter to the, or like inside the braces, not as a parameter. Since it's not a function, we can't say that, right? So inside the braces, just, or inside the parenthesis, just pass the base class name for the child class name and the entire part will be inherited, right? Next, super class. Super method. We can also apply, method overriding is what? So there was a function, just go back a little bit. Yes, there was a salary function, right? If you want to write a salary function with same name inside the child function, that means you want to override it in the child function, then you need to use the super keyword. How? See the example here. Here. So class country, sorry. So we are defining the constructor here, that country name will be initialized. After that, it will be at the inside the function, member function, that is country details, it will be printed, right? The country name will be printed. That's a small function, country. And now we are creating a child class, name as happiest country, and we are inheriting the country class here, right? After that, inside the child class, what we have written, we have initialized the constructor by passing the country name, continent. That means the constructor here is different. The country name, whatever the country name is passed to call the constructor of the parent class. That means within the constructor of the child class, the constructor of the parent class or the base class can be called by super keyword. Just see the difference. This init is the constructor of the child class happiest country, right? And inside this, we are passing the parameter country name and continent. But country name is the data member of the country class, right? Parent class. So that particular country name, whatever the value will be passed at the time of function object creation, this one will be sent to the parent class or the base class constructor by this super keyword. So super means the base class. Super will indicate or denote the base class. So super dot init, that means the constructor of the super class will be called from inside the base class constructor, child class constructor. And this particular country name will be passed. So when we are creating an object, we are passing Finland, we are passing Finland and Europe. That means Finland will be the country name and Europe will be the continent, right? So country name will be passed to the, once again, the base class constructor. That means here, Europe, Finland will be there and it will be set as country name. After that, Europe, the continent will be stored as Europe, right? So continent is a data member of child class. And in this particular function, country details, just we are printing country name and continent, right? And when it is being called, main is being called, see here, happiest country in the world. Happiest country in the world is Finland. The country name was a data member of the base class. That is also a member of the child class object. That becomes a child class object data member. And of also the unique data member of the child class, that is the continent, is also here. And we are initializing the the base class data member by using this super keyword. I think I can make it, I have made it clear, right? So by using super keyword, we can call the member, the base class function from inside the child class function. Got it? So that is the use of super keyword or super function for overriding the member, some function, right? Overriding is what? A same function will be assigned in the child class as well as base class. So at the base class, the method is being overridden, right? So that is today's content. That's all. Okay. So now just a little bit summary of today's class. First of all, we go through the function, how to create a user-defined function, how to create a lambda function. After that, we have gone through the object-oriented programming concept, that what is an object-oriented programming concept is, and how Python programming is satisfying the characteristics of object-oriented programming concept, that is the class, object, the inheritance, like that. Got it? Some more are there that will be covered and in the next class, right?
At the virtual
Okay,
session.
thank you, ma'am. I think it's a very nice session. Tomorrow we will arrange a question answer session more on that, so where they can directly ask a question on that.
At this stage,
Okay.
it's low.
So thank you
Because
everyone
it's
for
a
that, for
function
today's
separate,
session.
it's required to deliver the migration.
Thank you.
And
Thank you.
remember
there's
this was-
supposed to be a cloud